Hi, today I will present our work on CNAME-based tracking and our paper called The CNAME of the Game, Large-Scale Analysis of DNS-based Tracking Evasion. Our work was in collaboration with Gunesh from COSIC, Lukasz, an independent researcher, and Wouter and Tom from DistriNet. Traditional third-party tracking works in the following way. When a user visits a website that uses a certain tracker, in this case tracker.com, the browser sends a request to both the website and the server of the tracker. The tracker then responds with a cookie containing a unique identifier for the user. This cookie is stored in the browser under the domain of the tracker. When the user visits a different website embedding the same tracker, the identifying cookie will be sent along with the request to the tracker. This way, the tracker knows that it was the same user that visited both websites and is able to build a behavioral profile of the user. So this raises privacy concerns for users on the web. For this reason, there are a number of tools that users can employ to protect their privacy on the web. On the one hand, users can install extensions, browser extensions such as AdBlock Plus, Privacy Badger, and Ghostery, which block requests to third-party trackers altogether. On the other hand, some browsers have built-in tracking protection. For instance, Safari has its own mechanism called Intelligent Tracking Prevention, which basically deletes cookies on websites that haven't been accessed in a while, preventing cross-site tracking. Firefox has tracking protection enabled by default, and while Chrome does not provide tracking protection by default yet, it is planning on phasing out third-party cookies altogether in the future. So on the one hand, we have publishers who use the services of advertisers and trackers to monetize the content, versus the users who try to protect themselves from online tracking by using tracker blocking tools. As a reaction to the use of those tools, trackers try to come up with new ways to circumvent them. Our paper studies one of the most novel techniques used by trackers called CNAME-based tracking, which works in the following way. Instead of issuing a request to the third-party tracker, the website visited by the user issues a request to a subdomain of the website. The subdomain is used by the tracker, in this case track.example.com. The tracker responds with an analytics script and sets a first-party cookie. It looks as if the request is simply fetching a resource from its subdomain. However, on the DNS level, the first-party subdomain of the website is linked to a third-party domain belonging to the actual tracker. The request disguises itself as being a first-party subdomain of the website, therefore circumventing blocklist-based tracking protections. It is important to note that as the tracker is included in a first-party context to the visited website, the tracker will not be able to track the user across different websites. CNAME-based tracking is a type of first-party tracking. However, this limitation can be bypassed by using cookie syncing, as we will see further in the presentation. So how do we detect CNAME-based tracking? First of all, we need CNAME records, and not just any kind of CNAME records, but CNAME records from a first party to a third party domain. In our example, we would look for a CNAME record from track.example.com towards x.tracker.com. For our analysis, we used the public dataset of HTTP Archive, which contains millions of frequently visited websites from the Chrome User Experience Report. And using this dataset, we looked for first-party requests to a subdomain of the same site. Again, from our example, we looked for requests from example.com to tracker.example.com. And by combining these two steps, we are able to set up a list of CNAME tracker candidates. However, not all services that use CNAME records are per se trackers. For instance, CDNs also use CNAME records to connect with their customers. So in the third step, we perform the manual analysis on each of the tracking candidates. We analyzed their website and we looked for references to tracking or analytics or features mentioned on their website that require tracking or analytics. So we obtained 13 manually verified trackers, and for each of these trackers we constructed a tracker-specific fingerprint, which allows us to distinguish actual tracking requests to the CNAME trackers from other traffic. In the last part of our analysis, we ran an additional crawl with a different user agent, namely Safari, and we found one tracker that was only tracking Safari users. They also branded themselves as specifically circumventing Safari's intelligent tracking prevention. This table shows our results. For the 13 different trackers, we detected the number of publisher websites using them, and we also estimated the actual number of websites using them, and this number is a lot higher. We achieved this by using reverse DNS. We also noted the price of the service if it was available on their website. And finally, we had a look at whether the uBlock origin tool on Firefox and on Chrome was able to block requests to those CNAME trackers, and whether the tracker was included in the next DNS CNAME block list. This is a list which we also used to extend our list of CNAME trackers considered in our study. Interesting results are that a number of CNAME-based trackers are blocked by the uBlock origin extension on Firefox, but not on Chrome. This is due to the fact that Firefox has implemented a DNS level defense against CNAME-based tracking, which is technically not possible because of the limitations of the DNS API in Chrome. Further, we detected a number of CNAME-based trackers which were previously unknown to tracker blocking lists. We examined the popularity of publisher websites that use CNAME-based tracking according to the Tranco rank, or their popularity rank of their website, and we find that the CNAME-based tracking websites are heavily biased towards very popular websites. Almost 10% of the websites that use CNAME-based tracking in our dataset were in the top 10,000 most popular websites according to the Tranco rank. We also had a look at the categories of publisher websites that use CNAME-based tracking. As a baseline, we compare with the distribution of categories of the Tranco top 10,000 most popular websites during the same time, at the same time of analysis. And we see clearly that 40% of the websites belong to the category of business websites. To sum up, we found more than 10,000 publisher websites using CNAME-based tracking, most of which are businesses. 10% of them are very popular websites, and we found 13 CNAME-based trackers in varying sizes, and some of them were previously unknown to tracker blocking tools. I will now talk about the historical evolution of CNAME-based tracking. In order to do this, we again used the public dataset of HTTP archive, and we used a recursive approach where, starting from the most recent month of our analysis, we determined the amount of CNAME-based tracking in the previous month based on the CNAME-based tracking in the current month. So we obtained an analysis of 17 months, and here we show the results. We can see that throughout the whole period, CNAME-based tracking and its use has been increasing steadily. Same-site CNAME-based tracking refers to the use of a CNAME record that is same-site to the visited website, and cross-site refers to the use of a domain that is different from the visited website. However, in most cases, these domains were related or belonging to the same company. We compared CNAME-based tracking to third-party tracking, and we see that while the use of CNAME-based tracking keeps on increasing. The use of popular trackers is steady, while the use of smaller trackers keeps decreasing throughout our measurement period. In order to assess the effects on third-party tracking of CNAME-based tracking, we had a look at the specific evolution of third-party tracking. So we considered websites that had become recently customers of CNAME-based tracking. More specifically, we look at websites that were not actively using CNAME-based tracking for 6 months, then started using it and used it for at least 6 more consecutive months. And we found that on these websites, the number of third parties was unchanged, which suggests that CNAME-based tracking and third-party tracking are used by websites on a complementary basis in order to achieve additional information about the users. Finally, I will discuss the implications of CNAME-based tracking. We found some serious privacy and security issues arising from the way that the CNAME scheme is set up. First of all, we found cookies leaking to the CNAME-based tracker. Those were cookies that were scoped to the domain of the website. And we had a look at almost 9,000 websites using CNAME-based tracking, and we found that cookies were leaking on 95% of the websites. In the table below, we can see the most common origin of the cookie that was leaking to the CNAME-based tracker. For instance, Google Analytics sets a first-party tracking cookie on the domain of the website, and in a large amount of cases, this Google Analytics cookie was leaking to the CNAME-based tracker. So these leaks are not all intentional, but we also had a look at cookies that were leaking via request URLs, which could indicate the practice of cookie syncing, which is also meant to bypass tracking protections. We found that a number of the cookies were set by the third-party domain of the tracker, which clearly indicates the practice of cookie syncing. We also had a look at whether any sensitive information was leaking to the CNAME-based tracker. For this, we performed a manual analysis on 50 websites, and on 17 out of the 50 websites, we found some sensitive information leaking. The full name, a location, an email address, and in 10 cases, an authentication cookie was leaking to the CNAME-based tracker, and the last one also has some serious security implications. Finally, we also found a couple of issues, security issues arising from the way that the CNAME-based tracking scheme is set up. Because of the tracker being included in a first-party context to the visited website, we found a couple of security vulnerabilities, namely 2 major vulnerabilities that were affecting all of the publisher websites using this tracker. To sum up our study on CNAME-based tracking, our methodology allowed us to detect CNAME-based trackers that were previously unknown to tracker blocking tools. We performed a large-scale evaluation of CNAME-based tracking, and we found that the popularity of CNAME-based tracking has increased by 21% in the last 2 years. And finally, we found some serious privacy and security issues that arise from the CNAME-based tracking scheme. Namely, we found 2 major web security flaws present on web pages and some sensitive information leaking to the trackers. Thank you for your attention.